Here we're going to do another problem or two that involves moving a limit inside a continuous function. In this case, that continuous function is e to the x. But for some reason, it just feels a little bit different. So we're going to do some examples that kind of show how that works. So we're going to start with this example on the left. We're taking the limit as x goes to negative infinity of e to the power of 3 minus x cubed over x plus 2. How would we do that? Well, as I said, the first thing we're going to do is we're going to move the limit inside. So we'll be doing e to the power of the limit as x goes to negative infinity of 3 minus x cubed over x plus 2. And now we need to figure out how exactly we're going to do this limit, because it is a little bit weird. So what I would do for this limit is I would go ahead, as I've mentioned before, I'd look at the maximum power in the numerator and denominator. We have an x cubed up here and an x there, and I'm going to take the smaller of those highest powers and multiply by 1 over that. So I'll multiply both the numerator and the denominator by 1 over x. So that's going to be e to the power of the limit as x goes to negative infinity of, this will be 3 over x minus x squared over 1 plus 2 over x. And a lot of this goes to 0, so this goes to 0. This goes to 0. So this is going to end up being e to the power of the limit as x goes to negative infinity of negative x squared over 1. So I'll just leave it as negative x squared. And let's think about what's happening here. X is being squared, so even though we're going to negative infinity, that a negative squared is going to be positive. So I'm going to feel a little gross writing this, because I don't like writing infinity in an equal sign. But this is essentially saying e to the negative infinity. Okay, so what is that? Is that going to be infinity? Is it going to be negative infinity? Is it going to be something else? Well, the answer is it's going to be something else. What is it going to be? One way that we can write this, one thing you might know is that the graph of e to the x looks something like this, and it has a horizontal asymptote at y equals 0, the limit as x goes to negative infinity. I'll just actually write this out. The limit as x goes to negative infinity of e to the x equals 0. That's a fact we can know, but if you're not sufficiently convinced, this is the same as 1 over e to the infinity. And e to the power of a really big number is going to be a really big number, so that's just going to be 1 over infinity, which is 0. Again, this all made me feel gross writing it because I don't like writing infinities there, but you know, it served a purpose. It kind of helped us figure out what was going on. All that to say, just like we did in the previous example with sine, all we had to do was move the limit inside the function and life was good. So let's go ahead and do that here. And I think if you were to look at this, I'm going to write this in red because I'm about to do something wrong. If you're trying to do the same thing, I think your first instinct would be to do something like this. And unfortunately, that's horribly wrong. Why is that horribly wrong? Because this xth root is that's the thing that's going to infinity, and we just took it outside the limit. And moreover, we're taking the limit as x goes to infinity of a constant. So this is basically saying the limit is, it's weird. Don't do that. A better approach is that we want to rewrite this as, well, taking the xth root is just the same as taking the power of 1 over x. And with this, now we are all set to go to calculate our limit. We're going to move the limit inside the function. So we'll have e to the power of the limit as x goes to infinity of 1 over x. And thankfully, that is not the hardest limit. That is just going to be e to the 0, which equals 1. So as I said, it's pretty much the same approach we saw earlier. It just feels a little bit different because it's e. So don't let that fool you. We do the exact same thing as we do with other compositions using continuous functions.